This example is a trigonometry example involving two right triangles, where what the goal of the exercise in this example is to try to solve for theta. And if we look closely at our picture, we notice that theta is up here. We know one side of this right triangle, the triangle ABC, is 25, but however we don't know any other information except that it is indeed a right angle triangle. So we must look further into this question to try to decide how we're going to proceed. They have given us more information down in this part, where if we look at this right triangle, it's upside down, here's the right angle, they give us the angle 65 degrees, angle D, and they give us a side. So we have enough information to get started down in this triangle. So if we kind of think ahead a little bit, if we can find line segment BC, which we can also call side D, lowercase d, if we find that side first as our first goal, then we'll be able to use that number in our further calculation to find theta. So let's have a look at how that looks. So let's focus our attention right now down on this section of the graph, of the picture. We have 65 degrees here, we have 22 meters, and we're trying to find the missing side D. Right triangle trigonometry, we have to identify our sides. Side D we call the opposite side. Side 22 we call the adjacent side. And just so that we have it kind of complete, this is the hypotenuse down here. We know that because it is across from the 90-degree triangle. So that's just extra information that we don't need to use. We've got the opposite side and the adjacent side. Now, likely you've been doing some work with trigonometry, and opposite over adjacent is defined as tangent. So we're going to start this question off by realizing we need to find line segment D, and we're going to use the tangent function. So tangent of 65 is opposite over adjacent. That boils down to having a math expression of tan 65 degrees equals BC, which we could also have as lowercase d, so just know that you can change those, over side length 22. So our goal is to find side length BC. Because we could think of this as a cross multiplication question, we could think of having tan 65 over the number 1, and then we could further think that we could just cross multiply like this. We would then get the statement that BC could be found by multiplying the number 22 by the tangent of 65 degrees. So grab your calculators out, make sure your calculators are in degree mode. We check that in most calculators by hitting the mode button and then just double checking that it says degree. And then off you go and you proceed to put the numbers in. So 22 times tan 65 and enter, and you should come up with the number 47.179. It does continue. I did round. It is best if you can leave it unrounded in your calculator and use it further in the calculation. Just a little hint so that your numbers are a little bit more exact. So now we have indeed found the length of D. So let's just put that up on our picture so we have it. Side length of D is 47.179. We'll throw that in there so we have it up in our picture to refer to, like so. So kind of the first hurdle has been gone over. Now we're going to look to see how are we going to use that piece of information in this upper triangle. We don't need to call it side length D anymore now because we're going to focus our attention on triangle ABC. We know we have a right angle triangle. There's the 90 degrees. Across from the 90 degrees is the 47. So in this case, this is the hypotenuse. So I'll just put height there. Identifying the other sides. Theta is the angle that we're referencing. So across from theta is 25 meters. So we call that the opposite side. And just again to have it complete, this is the adjacent side. We're not interested in using the adjacent side. It's not helpful, but it's useful to have there. So in this case, we're going to be using opposite over hypotenuse. Opposite, hypotenuse, you might want to use the acronym SOHCAHTOA. haven't referenced that yet, hoping that by the time you get to solving two right triangles, you know that. And so we're looking at opposite and hypotenuse, which opposite and hypotenuse is going to be a sine question. So we get ready to go to the second step of the question, where we're going to find angle theta. It's going to be a sine question, so we're going to write sine of theta and then opposite, which is 25, over our hypotenuse, which is 47.179. Again, if you can leave that in your calculator, great. And if you can't, rounding it off to 3 or 4 decimals will probably not change the outcome very much in the final answer. Now, this is a little bit different calculation because we have to find an angle. In this first part, we had to find a missing side. So we could start by dividing 25 by 47.179. Do that. And that'll get you 0.52989, something like that. You can leave that in your calculator depending on how you put your buttons in your calculator, and that's a hard one to address in a short vignette. We want to make sure we use the second function sine on our calculator to give us sine to the -1. So again, most calculators go second function sine. This pops up on your calculator screen, and then you can put this number into it. And you can enter, and you should get somewhere close to 31.99, and then we would nicely round off to 32. So in this example, by doing two distinct steps, working with the lower triangle and then working with the upper triangle, we were successful in finding theta.